Hi, I'm Corey Martin, and I'm excited to be speaking at RailsConf 2021. Excited to be here with you virtually. This talk is about building a data pipeline in Ruby on Rails using the tools we know in the ecosystem. I'll be talking through an example of using familiar tools like Postgres, Sidekiq, Redis, and of course Rails to build a large-scale data pipeline. What is a data pipeline? So there are many familiar examples out there. In the open government space, in the US, the federal government will often publish data sets. One example is spending on political campaigns, and they'll publish this in a format like giant text files, maybe an API, and an app like OpenSecrets consumes that data and makes it available to people in more of a user-friendly way. In a very timely fashion, there are sites to help people navigate the COVID pandemic with open data. Well, not necessarily open, but this site, cvscovidalerts.com, scrapes the CVS website to monitor vaccine appointment availability. And as a user, you can go on this app, input your phone number, and receive a text when a vaccine appointment opens at a CVS near you. So that's a great example of using a data pipeline, in this case scraping the CVS website, really as a public service. Lastly, in your job, you might deal with ingesting data from, say, a vendor. Maybe you pay for the data. A company working with Internet of Things devices might, consume a data stream from those and then surface those in an app. There are many use cases that we might run across in our volunteer work or in our day jobs or in side projects that require bringing data in from somewhere else into our apps. Now, this can be very empowering. Say I'm a developer, I'm looking to grow my portfolio. Building an app based on open data ingested from a public source can make that app very useful to a lot of people. One example, building a doctor finder with Medicare data. There examples abound of useful apps you can build with freely available data. This makes someone looking at the app more likely to find it useful. There's not the blank slate challenge that you often find when you're building your first apps for practice or to grow your portfolio. So I always recommend keeping in mind this amazing space of building an app based on a data pipeline from an open data source. And that's exactly the example we'll be talking about now. Data pipelines have sort of a reputation of being expensive. There's a legacy, or just a term that's always been used, ETL. It means extract, transform, load. And when you think of like ETL software, often you just assume it's really expensive and for big enterprises. And sort of acronyms have a habit of implying that. But really all it's saying is you're extracting data from some outside source, transforming it to the structure that you need for your app, and then loading it into a database that is accessible to your app so it can be useful for your users. So it's actually explaining a very simple concept, and it's not exclusively in the purview of like specialized expensive tools. In fact, it's not even in the purview of non-open source. You can build an ETL entirely with open source tools like we'll be doing in this example, in this case specifically in Rails. When you build a data pipeline, you have a lot of options, right? You have enterprise software, including hosted solutions from Google Cloud and AWS. You have open source software that you would host on your own infrastructure that's really specialized for pipelines like Apache Spark and Apache Beam. Going down to the sort of closer to Rails options, you have gems. An example is Kiba, which is a ETL gem that mimics a lot of the concepts you might see in the more enterprise tools and brings it home to Rails. Definitely worth having a look at. But what we'll be focusing on today is the really familiar tools in the Rails ecosystem. Postgres, Sidekiq, Redis, Rails, the stuff we work with day in, day out, oftentimes as Rails developers, and just applying them to the data pipeline use case. So we're going to use an example to illustrate how we would build a data pipeline with Rails and familiar tools in the ecosystem. And the example we're using is familiar to many of us, Chipotle. Love their burritos. And believe it or not, Chipotle hires lobbyists to represent them to the US federal government, particularly to Congress. In this case, this year and the past few years, they have hired a firm, DLA Piper, which is a large law firm in DC, where I live. And DLA Piper represents Chipotle to the federal government. When they struck this relationship, DLA Piper had to file a form with the US Congress. And in fact, they have to file it quarterly for the length of their relationship with Chipotle, as long as they are Chipotle's lobbyist. And those forms are all made available to the public in giant zip files with a bunch of XML files in them. And that is our data source for this example. This is an example of what the relationship between Chipotle and DLA Piper looks like in Lobby Focus, which is an app that I made on my side time that consumes this open lobbying data and makes it presentable in an app that you can search and browse and index and click around, stuff like that. You can see that Chipotle paid DLA Piper about $190,000 in 2020, and you can see all of the quarterly filings here. You might be wondering, what is Chipotle lobbying about? And I actually want to show you the app so we can find out together. So this is my app. I'm watching certain companies and firms, and I can see their activity in a feed here. And if I search for Chipotle, I can click into their profile and see who they've hired, which is just one lobbyist in Q4 2020. And if I click into that lobbyist, I see the relationship. And this is a Rails app using a Postgres database. And we'll be looking at how the data actually got in here. But looking at the latest quarterly filing, this actually links to the XML file that we've ingested, hosted by the US Senate. And you can see here in the filing that their lobbying is around the federal response to the coronavirus pandemic. This might be related to stimulus legislation and how it affects Chipotle. For example, they might get funds from such legislation, and they want to have a representative to make sure that their interests are sort of taken into account in the drafting of stimulus legislation. That's my guess as to what this means. Certainly not a legal opinion or anything like that, but just wanted to show you an example of what you might be able to find out with the data that we're consuming here. Brief water break. This is the data source, the US Senate website, and you can see here that they publish these quarterly zip files. You can also see that the format will be changing soon, and we'll be talking about change in data pipelines toward the end. That's always fun. But for now, they're still offering the zip files stacked with XML or filled with XML files that we'll be parsing in our data pipeline. And as I mentioned, we're using really familiar tools in this example, and I'll explain what all these mean as we go through the steps, but you might have heard of a lot of these that are listed on this slide. Sidekiq, Nokogiri, Postgres, AWS, gem for writing to an S3 bucket or reading from it, HTTP Party, which is an HTTP gem, as you might expect. There are a bunch of them out there for Ruby, Redis, Ruby Zip. So these are all readily available gems that you can bring right into your Rails app. And this is sort of a high-level view of what the pipeline looks like. We start by scraping a web page, which is the page we looked at a couple slides ago with the zip files listed. We download those zips, we extract the XML files from the zips, we extract the filings from the XML files, and we load the filings into Postgres. And we'll look at all these steps in more detail, but we're basically like just exploding everything out until we get to the filings that we need, and then we're putting those into Postgres with some related information as well. The first step here, that one box in the left of the diagram we just looked at, is scrape. And that's when we look at the web page and we get the zip file locations that we want to ingest. And it's a matter of looking at that table, using Nokogiri to actually parse the HTML, because when I wrote this, there wasn't an API, like a JSON API or anything like that. You had to actually scrape the web page, look at the table, get the links, and you can see we're using some XPath code here to figure out what the zip file links are on this web page. And then we're launching a zip downloader job for each of those zip links to actually download the zip file and unzip it and then do stuff from there. So it goes from one Sidekiq job for scrape to another one for each of the zip files. So this is actually spawning off multiple Sidekiq jobs from one. And a little optimization here that you might find useful in your pipeline as well is we're caching the last modified date for each zip file before we process it. After we process it, I should say, we cache it. And then before we process it again, we look to see if we've already processed a zip file that was modified on the same date. And if that's the case, we don't need to process it again because there's no new data. So we use Redis, which is a simple key value store system, to have that cache. We say for this file, this is the last modified date that we processed for it. And Redis is easily usable from rails.cache. And I believe Rails is releasing an even easier way to use Redis for more custom use cases like this as well. Sidekiq, I don't know if I've explicitly said what that is. It is a background job processing framework. So you write little background jobs and Sidekiq orchestrates them. So you can queue up a bunch of background jobs at once and Sidekiq will step through them over time and show you what jobs are running now, what jobs are in the queue, what jobs completed successfully and what jobs failed. So it really orchestrates the whole pipeline. Sidekiq is an amazing tool, and the basic version is free, and there are premium versions available as well. It's really a staple in the Ruby and Rails world. And once we know that we need to process this zip file, again, we download it, and we look at the XML files within that zip. And we want to ultimately process every one of these XML files, but we're going to stick with that strategy of spawning off new, smaller jobs. We're going to spawn off one job for each of the XML files in the zip. These XML files are where those lobbying filings actually live. There are about 1,000 filings in each XML file. So we unzip the file, the zip file, into S3. We put every individual XML file into S3. And again, we're using a very commonly used gem, the AWS SDK S3 gem, to write each of the XML files from the zip that we're processing in this job into S3. And then we get the path of the file, what S3 names the key. And we can pass that key as an argument to the next Sidekiq job, which is responsible for processing an individual XML file. So if we process a zip here, we're unzipping it and then spawning off a separate Sidekiq job for each one of the XML files. And as promised, I'll make sure that we've spoken about all the tools listed here. RubyZip is just a simple interface to unzip a file and do stuff with the contents of it. HTT Party lets us retrieve the zip file from the US Congress. There are many other libraries you can use for requests like that. This is just the one that was my preference at the time. And again, this is a Sidekiq job. Everything in the pipeline is a Sidekiq job. Now, we have a job that is processing one XML file. Within each XML file, we have about 1,000 filings. And these are XML entities. So it's like a tag almost, filing. And then under that, you have basically the fields of the form that DLA Piper would have filed for their relationship with Chipotle. And we want to, within the XML file, extract all of the filing elements. And again, we use Nokogiri to do this. Within the file, we loop through all the filing tags. We write the XML of each filing to Postgres. Now that sounds a little weird. We haven't even processed the filing yet. We haven't really even looked at what the fields say. But by writing each filing string to Postgres, we can spawn off a job that actually processes that single filing that we've extracted from the file. And the only thing we need to pass to that job is the record ID in Postgres that contains the raw XML of that filing. So again, we're fanning out, we're spawning off more jobs because within the XML file, we have 1,000 filings and we're spawning off a job for each one of those filings using Postgres as sort of an intermediate storage layer where we keep each individual filing's raw XML so that it can be consumed by the job that is just processing one filing at a time. And this we call fanning out. You start with one scrape job, it spawns off multiple download jobs, which spawns off multiple process jobs, which spawns off multiple download jobs. But I'm jumping ahead, that's in the next slide. The point is, you're going from these monolithic jobs like scrape, which scrapes the whole web page and it gets all the zips, to much, much, much smaller and smaller and smaller jobs until you're at a point where each job is processing just one record. So if that job fails, you know exactly which record has weird stuff in it. Because with a data pipeline, you'll find that one of 100,000 records has wonky data, and you don't want to fail your whole pipeline in that case. You just want to fail that one record. So then you can look and see what's wrong with this record? Do we need to adjust the pipeline? Do we need to speak with whoever the data source is, etc.? So it makes failures a lot easier to diagnose if you have the failure itself limited to just one record. It also allows for great parallelization with Sidekiq. If you have all these really small jobs, you can have Sidekiq run 1,000 jobs at once. The concurrency setting is up to you. As long as your database can handle the load of all those records being written to it, Sidekiq, you can just add more and more and more workers to process more and more jobs at once, and it's extremely horizontally scalable. We'll talk about scaling limits later, but in general, Sidekiq is really good at processing a lot of jobs at once. Sidekiq itself will never really be the barrier to scale. It also provides a great dashboard where you can see the status of your running jobs. How many jobs are running right now? How many are in the queue to run? How many have failed? What were the failure error messages? The dashboard is just really invaluable. It means you don't have to build out as much monitoring tooling for your pipeline yourself. Just use what Sidekiq offers you. Excuse me. Okay, this is another view of the fan out. So as I mentioned, we start with this scrape job that's looking at the whole page. And so technically, if we were to scrape like all the lobbying records available from the US Congress, it would be about 1 million records. And that scrape job sort of has all 1 million records in scope because it's scanning that web page, getting the zip file list. Within those zips, within those XMLs, there are 1 million records. That's a lot of responsibility for the scrape job, but all it's really doing is reading a web page and then passing the rest off to the next step of the pipeline. The download job is working with one zip at a time, like we talked about. One zip has a bunch of XMLs in it. Together, they have about 25,000 records. So if a download job fails, you're not processing about 25,000 records. But again, the responsibility of that job is pretty limited. It's just downloading and unzipping a file. It doesn't really care what's in it. So it's unlikely to fail. You get now to the process jobs, which process one XML file at a time. It doesn't really care what the fields are within a filing. It just cares that one XML file has a bunch of lobbying filings in it with a certain tag name. So again, pretty unlikely to fail. And each of those jobs is responsible for 1,000 records. Finally, each filing gets its own load job. This is the most likely job to fail because one specific filing is the most likely to have some data inconsistencies in it. Maybe there's a weird date format in just one lobbying filing. I've seen this happen. If that's the case, that load job will fail, but that load job is only responsible for one record. So if a load job fails, you know exactly which record you need to go look at and address in some way in your pipeline. In the meantime, all the other jobs are still going, still succeeding. And so you're missing as little data as possible at your final destination, in our example, in the Postgres database. So we might load all the lobbying records since 2013. A few of them fail, but that's okay because we know which ones those are. We can see them right in the Sidekiq dashboard. And the others have successfully processed and are available in the app. So regarding that load job that looks at just one filing at a time, this is one of Chipotle and DLA Piper's filings in XML format. And we're extracting the fields we need from that XML filing entity with Nokogiri. Again, very critical tool in this particular pipeline because it's so XML heavy. And these are just example fields that we're getting from the filing. We're pulling out the client and we're pulling out the firm. Ultimately, this filing in the XML file is sort of like flat data. It's like the filing, the client information, the lobbying firm information. It's not really relational. It's just all listed out for every filing. We want to make it relational in our Postgres database. We want a clients table, a firms table, and a filings table. Because when I go to a client's profile page in LobbyFocus, I want to see all the firms that it works with and all of the filings that it has. And the data has to be related in Postgres for me to be able to do that in my Rails app with simple ActiveRecord. And to that point, we first make sure there's a client record for this client. We are using create or find by to make sure that if we have a client with the same name, we're not duplicating the record in Postgres. And this is a built-in ActiveRecord function. We're writing the firm record as well in the same way. And then we're writing the filing associated to the client and firm records that we've either written or looked up if they already exist. We're using a function that I made for this purpose called create or update unique. And in short, what it's doing is looking at the fields that are unique about a filing. So in this case, each filing has a unique Senate ID. So if we run this pipeline a couple of times and some stuff like misses the cache and we end up processing the same lobbying filings over and over again, we can rest assured that we're not going to have duplicates in the database. The way we avoid duplicates when we reprocess is having a unique index on the field in Postgres that is unique to a filing. So the synod ID is always unique. We will never have more than one of the same filing in the filings table. What we will do is try to write the filings straight away. And if that write fails due to a unique index violation in Postgres, we'll update the existing record with any fields that have changed from the existing record in the database. So this way, if the pipeline runs again, if existing information has been changed in the data source, we'll capture that, but we'll never write more than one of the same record. We won't have any duplication in our database. This generally is called idempotency, meaning you can run the thing again and again and again, and it's okay. Normalizing is important depending on the data source. Something interesting specific to lobbying data, but you might run into this in your own data set, is that company names are not standardized. So you could have 4 different versions of Microsoft. Here we have Microsoft in all caps, Microsoft Corp, Microsoft Inc., Microsoft Corporation. They all mean Microsoft, but it's like a free-form field when a lobbying firm files a lobbying report. They can type in whatever they like, and they're all going to have a different way of expressing Microsoft. So there typically, when you hit a problem like this in a data pipeline, is someone else who hit the same problem who may have released a solution to the open source world to help address that problem. And indeed, in this case, for company names specifically, there's the consistent company gem, which will normalize all those Microsoft names to just Microsoft. And you can do a unique index on the normalized name, for example, in the clients table, so you're not writing all these multiple versions of Microsoft. You're associating the lobbying filings that spell Microsoft every which way with the same one Microsoft in your clients table. Because the last thing you want is to have somebody like search your app for a company name or whatever your data is and find 5 different versions of that. Sometimes you do need to normalize the data if the data source isn't normalizing it for you. Stuff changes. So this has happened to me a few times on this project where there'll be a new field added, removed. What was a web page is now a JSON API. The data format completely changed. All of these things can happen if you're not controlling the data source. And because we've built this pipeline modularly with like very narrowly scoped responsibilities for each job, you're able to make the lowest amount of change you can to address the change in the data source. For instance, if that web page showing all the zip files, if their layout significantly changed and we had a hard time scraping it, we would just fix that scrape job and leave the rest of the pipeline as is. If we had more of like a monolithic spaghetti pipeline, then we might have to make a bunch of different changes in different places and it would feel really brittle. But because we have these separate sort of jobs with their own specific responsibilities, we can, in many cases, just modify one job to handle a change in the data source. So you really want to optimize for the ability to change. And the best way to do that is the fan-out approach and modularity in your jobs, in my opinion. You might be wondering, will this scale, right? It's like the forever question that stereotypically has been asked about Rails apps. I don't think it's the right question, but it is a question we need to answer when productionalizing stuff. So we're building this pipeline on Sidekiq. Sidekiq in and of itself is extremely scalable. So if the data processing is not moving as quickly as you might like, you can add more Sidekiq workers. If the issue is CPU, right? Add more Sidekiq workers and Sidekiq will be able to process more jobs in parallel. If the loading to Postgres is slow, well, in the same way we horizontally scaled Sidekiq by adding more workers, we might need to vertically scale Postgres by beefing up the Postgres instance with more memory or more CPU. You will hit limits though, and you have to look at the amount of data that you're processing and the amount of time you want to process the data in. Independently, neither of those will block you, but together, if you have a ton of data that you need to process really quickly, you're more likely to hit a hard scaling limit in either Postgres or Redis. Redis is what is storing the pending jobs list, and that can run out of memory. And you can really only, in most cases, vertically scale Redis, and eventually you're just not going to be able to get more memory in there. And you might not be able to hold all of the jobs that you want to process or are processing now. This is unlikely to happen in the vast majority of projects, but if you do hit that point, you have options. We talked about this list of different data pipeline tools out there. If the Magenta, what we talked about today, isn't working for you, you've tried the familiar Rails approach, you're hitting a hard scaling limit, generally in either Postgres or Redis, and you don't see an alternative, you can look to Rails gems like Kiba, which specifically address the ETL use case and might have a solution in there or an optimization. Or you can look at these more enterprise data pipeline tools that are more, I guess, MapReduce or are really primed to take a lot of data and split it up in really, really smart ways to parallelize the processing and make it really, really fast. But again, most use cases, you might not need that. And so it's worth considering the approach we talked about here, where we use these battle-tested tools that are really familiar in the Rails ecosystem. And I'm personally really excited about the possibility of this approach being used more, because I believe it's extremely fast to ramp up and highly scalable. Speaking of excited, there are lots of opportunities here. So if you're building a portfolio and you'd like to have an app out there that shows your skills, which is how many of us started off and still have to routinely do in our careers, having real data in there makes the app potentially really useful right out of the gate. So many examples, right? Like you could scrape Medicare data and make a doctor directory with Medicare ratings in there. You could scrape weather data. You could scrape Wikipedia. You could do all sorts of things with freely available data, building your own data pipeline, and then building a UX around that data that is really useful to people. Whether you're working on your front-end skills, your data processing skills, your Postgres skills, there are really a lot of opportunities to use open data in a data pipeline to make a killer, not even example app, just a killer side app that is really useful for people. Likewise, you might hit a situation at work where you have to work with an existing data pipeline or build a new one. Having the experience of building a pipeline from start to finish and operationalizing it, even in a side project, is extremely valuable. And a lot of the lessons you'll learn around scalability, sort of where the choke points are, normalizing data, dealing with just like funky data stuff, is applicable to, you know, the corporate world, big enterprise, because they might have fancier tooling, but at the core of it, they're dealing with a lot of the same issues you'll hit with much smaller data pipelines. So it's just a really valuable experience, and it's accessible to all of us as Rails developers. So I want to thank you for taking the time to attend this talk, this virtual talk. I hope that next time I can see you in person. But in the meantime, I'm having a Q&A. So check the schedule and I'll see you on Discord, and it would be great to have a chat with you and answer any questions or address any feedback that you have about the talk. Thank you so much for attending.